Okay, hi everybody. So, if you watched the previous video, you should know what the basics of a parametric equation is and how to graph it and how to derive the equation. So, today we're going to focus on how to find the initial condition and the direction of a point given a plane curve and how it rotates around it. So, if you looked at the last episode, you focused on using these two equations, and given t, you would find x, and so on. Today we're going to focus on using the matrix version. So if you want, there's also another video on the same channel which talks about how to find the matrices of these two equations. But today we're going to focus on how to graph them. So this is our example today, because the numbers are pretty simple and easier to find. So it's going to be 9 cosine 2 pi over 9t and 3 sine 2 pi over 9t. So this is the equation of our ellipse. It's probably the simplest you can find. It ends up being major axis on the y-axis and minor axis on the y-axis. So, okay, so in the beginning, if you want to if you plug this into your graphing calculator, or if you want to graph it yourself, the initial condition of the first point would be at 9, 0, and it would rotate this way. And the reason it would rotate because you plug in t, everything from 0 to 9, it will move from here and go this way around, because as x decreases, y increases, and so on until it reaches back to that point. And it also continues around if you increase t some more. T is always increasing, which is what we assume in this term. And if you turn both of them negative, so if you change these equations here to negative equations, it would still rotate the same direction, but instead of starting on a positive x-axis, it will start on the negative x-axis. And it would still go counterclockwise, so it would end up going this way. So the graph would move from here and going this way, it would go around. And the same reasons before, if you plug it in, it will be going this way. And of course, if you do positive, if you turn this one positive and that one's negative, it will start at this point, because x and y would begin at the same point when t is equal to 0. But instead of going this way, it would go the other direction. So here it would go this direction and go around back to this point, because in the beginning x would decrease and so would y would decrease as well. And if you're about to change this one to negative and this one to positive, so you would change these here, then instead of starting over here, it would start over here, but much like the equation beforehand, it would go clockwise, so it would go this way. And the same reason stands. You can check your work by plugging in different values for t. So that's basically how you would find a point given those equations. The simplified version of how to remember this is just positive, negative, negative, positive, and you try to figure out which way it goes. If you forget how to find these equations, you could always just plug in numbers for t and see which direction it goes. It's a constant speed for t, because assuming that we plug in t as an integer, it will constantly speed through here without a change in speed. So that's how you'd find the initial condition for that point. So here we can change our example and see what would be different if we were to change our equation. So instead of having cosine and sine, we're going to change it to have x and y equal to 9 sine 2 pi 9t and 3 cosine 2 pi 9t. And if you want, you can pause the video here and try to figure out and make a guess on where the point would start and which direction it will rotate. Okay, so let's see if you were right. So in the beginning, if you have these two equations, if you leave them both positive, it would be slightly different than this graph. The ellipse would still be in the same form and the same shape. So the form of the ellipse would not change, but the starting point of the point will. So if you leave them both positive, it will begin at 0, 3. So instead of starting on the x-axis, it will be starting on the y-axis, because sine will be coming first. So it would start at 3, 0, and it would go clockwise instead of counterclockwise first, even though they're both positive. So it would end up going this direction as x increases and y decreases. And then if you were to change both of them to negative, then you would start, instead of on the positive y-axis, you would start on the negative y-axis, and it would still go clockwise, which means it will still go this direction as x decreases and y increases in the beginning. You can also check your work with plugging in values for t. And same as before, we'll try and test it out if positive, we're changing the signs, it'll change where to go. So if you were to change the first equation back to positive and leave the second one negative, it would start at 0, -3, because if t equals 0, then the x value, the y value will still be negative, but instead of going clockwise, it would go counterclockwise, so it would go in this direction instead. And if you were to change it to negative, and this one back to positive, then it would still go like the first example. It would still go in a counterclockwise direction, but instead of starting on the negative y-axis, it will start on the positive y-axis, and it would still go counterclockwise. It would go the opposite direction, and it would still constant speed change from before. Speed doesn't change. Generally, this is how it's going to go. So, back to me. So, in general, this is how you're going to be able to find the initial condition of any point given t. This is how t would rotate around an ellipse. Come back and check our channel if you want any more information. The end.